This is Take 5 with Bentley, Nevada. In the studio once again is Tanya Woods, Global Product Compliance Leader for Bentley, Nevada. And Tanya, we've had a pretty rich series of discussions here about hazardous area approvals and just certifications in general. The investment that Bentley's made in the business over the last decade or so, they've always been, I think, quite good at it, but it sounds like they've become better in the last decade. And the concepts of how you deal with hazardous areas has been evolving. I mean, if you go back far enough, people basically said, we're not going to stop an explosion, we're just going to contain it. Concept of basically explosion-proof housings and things. You don't tend to see those much anymore, do you?
We still see them. Bentley, Nevada does not rely on explosion-proof housings for our protection. They're very expensive. They're very cumbersome. You're familiar with what they look like, right? So the stand that Bentley, Nevada has taken is that we will design our products so that inherently they're not going to cause an explosion. So the sensors with the Intrinsic Safe, the power levels are so low, the amount of energy contained anywhere in the circuit is so low that it won't cause an explosion. And then with our monitors that are zone 2, we're using this increased safety protection concept where we have no arcs, no sparks, no hot surfaces, nothing like that that's going to cause a problem.
So you've got kind of the antiquated explosion-proof idea of containing the explosion, and then the others really rely more on preventing the ignition from happening at all. You mentioned there's intrinsic safety, and then there's a level kind of beneath that. It's not quite as stringent. Increased safety, is that what you call it?
That's right. Increased safety.
But so IS is actually intrinsically safe, not increased safety, and there's a different abbreviation for increased safety?
It is. It is EC is what we're using for our zone 2 increased safety concept.
The idea then again of increased safety is that's what you'd be using for these zone 2, div 2 classifications. The intrinsically safe is what you'd need for the zone 0 and div 1.
Correct. Those are our 2 primary methods of protection that we use.
So are the sensors themselves generally considered intrinsically safe, or do you need some kind of a barrier, whether it's a Zener barrier or like a galvanic isolator? Do you need some intervening piece of gear between the monitoring system and the sensor typically?
Yeah, that's very common for intrinsically safe type of environment. And that's because you always want to ensure that you're limiting the amount of energy that can go out to a sensor, right? You can make the best sensor in the world that's very low power, low energy. But if you connect it up to, say, a 250 volt supply, now we've overpowered it, and that could be a problem, right? So we have the barriers, like you've mentioned. You would always connect something up to some kind of energy limiting type of source, whether that's some kind of fold back circuit or a barrier or something like that, to make sure you're not going to overpower, overcurrent these types of devices.
Right. And for those who aren't maybe familiar with some of these devices, they're actually pretty simple. They have things like Zener diodes, and you can think of it almost like a fuse. If you try to put too much out there, the device is going to prevent that from happening, and it's not so sophisticated that the likelihood of that thing failing is high. It's quite low. How often, particularly on offshore platforms, you will see people gravitate towards galvanic isolation as opposed to Zener barriers, because the requirement to maintain a pristine ground in a Zener-based system is pretty high, and that can be tough when you're in these saltwater environments and things. Do you see the galvanic isolation concept expanding outside of kind of those marine environments?
I looked at our data once coming through the panel shops, and it seemed like most of our panels are built with galvanic isolators. And I didn't poke too much into it. I made the guess, I get that if you're going out to a customer site, I would envision that you would do a site survey first with an engineering team. And if they're going to do intrinsic safety, yeah, you want to make sure that you have that really clean, good, intrinsically safe ground. And if you don't meet that requirement of a 1 ohm ground that you need, then barriers are off the table and you're going to go for galvanic isolation.
I guess one difference is they're active devices as opposed to passive, but they do solve a lot of problems with maintaining that ground. And in some industries, it's probably just downright impossible to maintain that ground. Like I said, maybe offshore platforms and things.
Yeah.
So once again, we've managed to chew up all our available time, but it's been great having you in the studio, Tanya. We'll have you back at some point in the future, and we've covered a lot of ground. I think our listeners are going to find this very informative. So I want to thank you for joining us, and you have been listening to Take 5 with Bentley, Nevada, a Baker Hughes business.